Ever wonder how companies decide, with so many factors at play, what to charge for insurance, considering all the potential risks and payouts? It's a complex calculation involving numerous variables and a deep understanding of probability. Or how pension funds know, with decades stretching ahead, they'll have enough money decades from now to meet their obligations to future retirees. It's a long-term game, requiring careful planning and precise forecasting. It's not magic, it's actuarial science, a blend of mathematics, statistics, and financial theory. Actuaries are the math-powered fortune tellers of finance, not in a mystical sense, but through rigorous analysis and data-driven predictions. Using numbers to protect people, businesses, and economies from disaster, they quantify risk and help organizations prepare for the unexpected. They analyze past events, sifting through mountains of data, spot trends, identifying patterns and correlations, and build models to predict the future, projecting potential outcomes and assessing their likelihood. Think detective, uncovering hidden clues and piecing together the puzzle, mathematician applying complex formulas and statistical techniques, and futurist in one, anticipating potential challenges and opportunities. Their mission: manage risk, mitigating potential losses and maximizing financial security, turning life's uncertainties into financial plans, providing a roadmap for navigating the future. Actuaries use probability, statistics, and financial theory, the core tools of their trade, to bring order to chaos, transforming raw data into actionable insights. They're the calm voice saying, in the face of uncertainty, the future is unpredictable, but here's how we'll handle it, offering a strategic path forward. We'll explore what actuaries do, delving into their day-to-day responsibilities, how the field began, tracing its historical roots, and why it's so vital today in our increasingly complex world. Forget the stereotype, the image of a dusty number cruncher. This is a dynamic, high-impact career, shaping the future of finance and beyond. At the crossroads of math, business, and tech, actuaries are leveraging cutting-edge tools and techniques, ready to see how numbers shape a safer future, how mathematical models can provide financial security. Let's dive in and uncover the secrets of actuarial science. So, what is actuarial science? Simply put, it's the math and statistics behind managing financial risk, especially in insurance and finance. Imagine you and friends create a fund for cracked phone screens. How much should everyone pay? You'd estimate the odds of accidents and the repair costs. That's actuarial thinking. Actuarial science scales this up for entire industries, figuring out how much money to set aside today to cover future costs. Actuaries analyze the probability of events and their financial impact using probability, statistics, finance, economics, and computer science. Their unique blend of skills lets them tackle big questions, from pricing insurance to keeping pension systems solvent. Without actuarial science, insurance and retirement planning would be wild guesses. It's the invisible safety net that keeps our financial world stable. Pretty important, right? How do actuaries predict the future? It's a question that blends mathematics, statistics, and a deep understanding of risk. They don't have crystal balls, but they do have powerful tools. It all starts with data, mountains of it. Actuaries sift through vast data sets looking for patterns and trends that can help them understand the likelihood of future events. They use the law of large numbers, a fundamental principle in statistics. While you can't predict one person's fate with certainty, you can predict outcomes for large groups with a surprising degree of accuracy. This is the cornerstone of actuarial science. For example, life insurance actuaries use mortality tables, which are based on historical data, to estimate how many people in a group will pass away each year. These tables provide a statistical framework for predicting mortality rates. Then, they calculate the financial impact of those predicted deaths, considering factors like policy payouts and administrative costs. They factor in the time value of money, investing premiums collected today to cover future claims that may not arise for many years. This requires careful consideration of investment returns and inflation. Modern actuaries use powerful computers and sophisticated software to build stochastic models, which are essentially complex simulations. These models involve running thousands of simulations, each representing a different possible future, to prepare for a range of possible outcomes and assess the associated risks. This approach applies to all types of risk, from natural disasters to economic downturns. Health, property, pensions, you name it. Actuaries play a crucial role in managing risk across a wide spectrum of industries. The core principle: use data and math to understand risk, quantify its potential impact, then create a financial strategy to manage it effectively, minimizing potential losses and maximizing opportunities. It's logical, powerful, and essential for handling uncertainty in an increasingly complex world. Actuaries turn unpredictable events into manageable plans, providing a framework for financial security and stability. That's the real magic, transforming uncertainty into calculated confidence. Predicting the future with math isn't a new endeavor. It's a practice that humans have engaged in for centuries, driven by the fundamental need to understand and prepare for what lies ahead. From ancient civilizations attempting to forecast harvests to modern-day financial institutions assessing risk, the desire to anticipate future events has always been a powerful motivator. Indeed, its roots date back centuries, intertwining with the development of mathematics, statistics, and the very concept of risk management. A pivotal moment arrived in 1662 when John Graunt, a London haberdasher and one of the first demographers, created what is considered the first life table. Graunt meticulously analyzed mortality records using real, hard-won data to estimate human lifespan at different ages. This was a groundbreaking achievement, a departure from pure speculation towards data-driven prediction. Graunt's work laid the foundation not only for demography, but also, crucially, for the development of life insurance as we know it. By quantifying mortality risks, he made it possible to create financial products that protected individuals and families against the uncertainties of life. Later, the renowned astronomer Edmund Halley, of Halley's Comet fame, further refined these life tables, improving their accuracy and applicability. Halley's enhancements played a vital role in helping to accurately price life annuities, providing a more secure financial future for individuals in their later years. These advancements were instrumental in formalizing actuarial science as a distinct discipline, a field dedicated to assessing and managing financial risks. In those early days, actuaries relied heavily on tools like log tables, painstakingly calculated and compiled to aid in complex calculations. And of course, the indispensable slide rule, a mechanical analog computer that allowed for rapid estimations and approximations. These early actuaries primarily used deterministic models, which operated under the assumption that the future, by and large, would closely mirror the patterns and trends observed in the past. A significant milestone in the profession's development was the founding of the Institute of Actuaries in 1848, marking the establishment of the first professional actuarial body. However, the real revolution, the game-changing moment, arrived with the advent of computers, particularly in the late 20th century, as computing power became more accessible and affordable. Suddenly, actuaries had the capacity to process vast amounts of data with unprecedented speed and efficiency. They could also run complex simulations, exploring a multitude of scenarios that were previously unimaginable. This led to a fundamental shift towards stochastic models, which embrace uncertainty and randomness. These models allowed actuaries to explore thousands, even millions of possible future outcomes, each with its own probability. This was a radical departure from relying on just one single predetermined path. The relentless advances in both technology and finance have profoundly transformed actuarial science, reshaping its tools, techniques, and overall approach. The field has evolved into today's dynamic and data-driven discipline, one that is constantly adapting to new challenges and opportunities. From the informal gatherings in coffee houses where early ideas were exchanged, to the sophisticated computer labs of today, the core mission of the actuarial profession has remained constant: to make the unpredictable manageable, and to help individuals and organizations navigate the uncertainties of the future with greater confidence. Where do actuaries work their magic? Insurance is the classic example. Life insurance actuaries use data on age, health, and lifestyle to price policies and annuities. Health actuaries predict medical costs and design sustainable health plans, balancing ever-changing trends and technology. Property and casualty actuaries analyze risks like car accidents, natural disasters, and liability, setting rates to keep companies solvent when disaster strikes. Pension actuaries ensure retirement promises can be kept, modeling everything from workforce demographics to investment returns. They advise companies and governments on how much to contribute to pension funds. Actuaries also help public programs like Social Security stay financially healthy. Their work touches nearly every aspect of financial security. When you see stability in insurance or pensions, there's an actuary behind it. At Inspired, here's how you become an actuary. Start with a strong math foundation. Many universities now offer actuarial science degrees. These programs cover probability, statistics, financial math, economics, and programming, often in languages like R or Python. Some schools are centers of actuarial excellence, offering top-tier education and industry connections. Internships are key for real-world experience. But your education doesn't stop at graduation. The real test is a series of professional exams. Many programs help you pass the first exams while still in school, giving you a head start in the job market. Passing even 1 or 2 exams before graduating shows employers you're serious and capable. Becoming an actuary is a marathon, not a sprint, combining university study with ongoing professional development. If you love math and problem solving, this path could be for you. Graduation is just the beginning now, come the professional exams. The Society of Actuaries, SOA, and Casualty Actuarial Society, CAS, administer these challenging tests. Earning credentials like ASA, FSA ACAS, or FCS can take 6-10 years, often while working full-time. Exams cover probability, financial math, predictive analytics, and specialized topics. Companies support actuarial students with study time materials and bonuses. These certifications are the gold standard proof you've mastered the science of risk. The process is tough, but the rewards are significant respect, career opportunities, and a great salary. Achieving fellowship is a major milestone in the profession. It's the ultimate validation of your expertise. Here's the fun part. Actuary is consistently ranked among the best jobs for work-life balance, low stress, and high pay. Median salaries top $113,000, with experienced actuaries earning much more. The profession is small, just 30,000 to 40,000 certified actuaries in the US, making for a close-knit community. The future is bright. The Bureau of Labor Statistics projects 23% job growth through 2032, much faster than average. Why? The world is more complex and data-driven than ever. Actuaries are tackling new challenges, big data, climate change, and an aging population. The role is expanding into enterprise risk management, banking, investments, and tech. Actuaries blend math, data science, and business skills in high demand. With AI and machine learning, actuaries are more empowered, not replaced. The future belongs to those who can turn risk into opportunity. We've traveled from 17th century London to today's high-tech world, discovering that actuarial science is about more than math. It's about managing uncertainty. Actuaries build the financial safety nets we rely on, from insurance to pensions. The path is challenging, demanding years of study and perseverance. But for those who love math and real-world problem-solving, it's incredibly rewarding. Actuaries bring order to chaos, making a real impact on people's lives. In a world full of risks, their work is more critical than ever. If you want a career where you solve puzzles and make a difference, actuarial science could be your calling. The world needs more risk managers. Maybe that's you.